sudden polar bear is in distress. Help, 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 I'm dissolving. The brown bear says, well, a bear is not water soluble. Polar bear replied, it's easy for you to say. You're not polar. So polar bear is polar, will dissolve in water. Water is a polar solvent. Okay, so that will help you to remember like dissolved like. All right. So back to the chemistry part. Like dissolves like. Iodine can dissolve in water because of the dipole-induced dipole interaction. Iodine is a nonpolar molecule. Water is a polar molecule. Okay. Iodine can dissolve in water. However, carbon tetrachloride can dissolve, has a higher solubility for iodine. So if you dissolve iodine in water and put it in a test tube, and then inside that test tube you pour some carbon tetrachloride in there first. Now, once the water solution will not mix with carbon tetrachloride. However, if you cap that test tube and you shake it, the nonpolar iodine dissolved in water will be pulled into the carbon tetrachloride. Now, the color change, I think it has something to do with the camera lens when they took the picture there. There is no chemical reaction. You're just, iodine is being dissolved from, iodine is being dissolved in water there. And now, when you mix everything thoroughly with the force, external force there, iodine will get into, from the polar solution, will get into the polar solvent, will get into the nonpolar solvent, because nonpolar solvent will have a higher solvent, similar type of intermolecular forces with the nonpolar solute. They will mix better as a result. This is the process that we call extraction. In organic chemistry, you can actually do extraction there. Based on the solubility, based on the intermolecular forces there, you can use extraction to separate things based on their different solubility there. Okay, so the solubility rules, and this is something that we talked about in chapter 4, and this is something that I need you to pay attention, because there will be topics on the questions in the final exam asking you what kind of compounds are water soluble, what kind of compounds are water insoluble. That actually has something to do with intermolecular forces, but mainly have something to do with the how strong the ions are attracted to one another. And this is something that I need you to memorize when you prepare for the final exam. And when you click on final exam on Canvas, there is a similar type of slide, and I took that slide off of my Chem 102 PowerPoint, and I posted there, rules of solubility. And this is the rules of solubility in your textbook there. Now, remember, we are going to ask you questions in the final exam and say, when you have these two compounds and mix them together in aqueous solution, which one is not going to be soluble? You have to remember, lithium, sodium, potassium, ammonium, these are, doesn't matter, these are the cations there. Doesn't matter who they are with. Their salt are always water soluble. Okay? For nitrate, everything nitrate is water soluble. For chlorine, bromine, and iodine, and when they combine with salt, everything is water soluble except mercury, silver, and lead. And those are insoluble. So you do need to remember these things, memorize these things. But if that's too much to memorize, remember you are allowed to bring in an index card when you go to the final exam there. So if you want, you can put that information on the index card. Okay. And you say, well, I don't really care the size of the index card you bring to the final exam, as long as it's one piece, as big as 8 by 11. Now, not a huge page, as big as 8 by 11. That's the maximum size there. You know, one piece. Okay. And the thing here is that you don't really have a whole lot of time when you take the final exam for each of the questions there. If you make that index card too busy, you may spend too much time searching for the information on that index card, and then I don't know how much that's going to help you or hurt you when you take the exam there. So just put some key information in there that you think that are important. This may be one of them, and you may want to write down this information there. And try to glance through this particular slide there, and try to remember some of the information in there. That way you don't have to only write down the exceptions there. Okay, that's how you remember this information there. Now, what's the application for this like dissolved like principle? Well, we can ask you these questions there. Will different compounds dissolve in a particular solvent and making a solution there? Well, calcium chloride and water. Now, in general, we will not ask you exceptions there. Anything chloride is water soluble, except silver and mercury and lead. So calcium chloride, just like sodium chloride, it's water soluble. Calcium bromide, hexane. How do you solve this kind of answer, this kind of question? Well, calcium bromide, you know, metal and non-metal. So that's an ionic compound. Hexane, non-polar solvent. Oh, they're not going to dissolve. Just like water and oil, they don't mix. Calcium bromide will not dissolve in hexane. Okay, so organic molecules, hydrocarbons, are generally considered non-polar. They're non-polar, will not dissolve. Ionic compound has a different type of intermolecular force than non-polar molecules there, so they're not going to mix with one another. Iodine is non-polar, hexane is non-polar, so they should dissolve. Now, sometimes things can get tricky there. Carbon hydrochloride and water, this is non-polar, this is polar. They're not going to dissolve. Just like oil and water, they don't mix. And this one, ethanol and water, methanol and water. Well, if you look at the molecules here, H2O, you can treat that as HOH. If you replace one of the H with CH3, you end up with methanol. So alcohol can actually dissolve in water to an extent, as long as you have only a few carbons in it. If you have more than 5 carbons, the alcohol containing more than 5 carbons will have extremely low solubility. And if you go beyond the 5 carbons, those alcohols will no longer soluble in water. And this is the term that we use to describe the solubility, hydrophobic, or hydrophilic to hydrophobic. And then in the alcohol part, if you look at the alcohol, okay, I don't know why we're spending so much time talking about the alcohol. That's probably what chemistry is all about. You need to understand the behavior of alcohol. So if you have the alcohol there versus water, okay, you can see one of the hydrogen has been replaced by what we call an R group, alkyl group, where you have 1 carbon, 2 carbons, 3 carbons, 10 carbons there. As you're increasing the number of carbons on the R group there, then you are increasing the non-polar component of that compound. If the non-polar component of the compound becomes dominant, then this entire molecule will not be able to mix with this molecule. Okay, so only low molecular weight alcohol can dissolve in water. When you go beyond 4 or 5 carbons, the solubility of alcohol in water is going to be much, much lower. So it's not going to have a high solubility there, simply because the non-polar nature has been increased so much. Then the alcohol will no longer be considered, high molecular weight alcohol will no longer be considered as a polar molecule, because the polar nature comes from the OH group there. And compared to the R group there, it's so much weaker. Now, question that we may have here is alcohol going to dissolve in hexane? Well, the answer is yes, because hexane, you have CH3, CH2, CH2, 6 carbons in there. You do have a methyl group in here. Now, water will not mix. Water will not mix with hexane. Oil and water don't mix, but ethanol, methanol will actually mix with hexane. Okay, another, simply because you have similar, one part of the molecule has a similar intermolecular force. So the key thing here is that like dissolve like. And that's what this particular chapter, well, that's one of the topics that we want to look at.